As a second lecture, we're going to talk about dissociation as a main point and main goal. Okay. Dissociation, hopefully you remember that I told you dissociation is the process of separation of ions. Look, the separation of ions that are already present. Well, process of separation of the ions. Well, and I teach you how to write the dissociation reaction. For example, we have barium nitrate. Barium nitrate, first of all, you have to know how to write its chemical formula. Look, without chemical formula, you will be disabled. You cannot do anything without a chemical formula. So, barium nitrate is BaNO3 by 2. Barium nitrate BaNO3 by 2. Look, BaNO3 by 2, I will write here. BaNO3 by 2. First of all, it's salt, so it will dissociate. Okay, during the dissociation reaction, water must be right here. We will write water here. Okay? And now, we have Ba and NO3. Ba plus 2 plus NO3, negative. Then, you have to balance. Balance. How many Ba atoms do you have here? 1. 1. Look, 1. It's balanced. How many NO3 ions do you have? Here, it's 1. But here it's 2. That's why we have to multiply by 2. Well, I like to write in a white page. Well, look. Barium nitrate, BaNO3 by 2. It will dissociate to producing Ba plus 2 and NO3 negative. Okay. Look. 1, 1. It's balanced. We have two nitrates, but here we have 1, so it must be multiplied by 2. Okay. This is first step, writing a safe dissociation reaction. Another one, AlCl3. It will dissociate into water, H2O. Okay? Well, what we have in this compound, Al plus 3 plus, and another one, chloride. Okay. And now balance. How many aluminum? How many aluminums? 1, 1. It's balanced. How many chlorides? 3. Here we have 1, so it must be multiplied by 3. It's balanced. Another one. Al2 SO4 by 3. Al2 SO4 by 3. Look, it will dissociate, right? It will dissociate. This is salt, aluminum and sulfate. Al plus 3 and SO4 negative 2. Well, and now balance. How many aluminum atoms do we have here? 2. Here is 1, so it must be multiplied by 2. SO4 is 3. Here is 1, so multiply by 3. Okay? So, by this way, you can write the dissociation reaction. First of all, separate ions, then balance. First of all, separate ion, break down your compounds, then balance each atom by each atom. Okay, last example. Look, last example. KPbOH by 3. It will dissociate, of course. Okay? K plus right? K, Pb plus 2 plus OH negative. Separate ions. Here we have K, we have Pb, we have OH. Okay? So K is 1, 1. It's okay. Pb 1, 1. Okay. 3 hydroxide anions. Here we have 1. So multiplied by 3. As a quick way, we can write and we can make our calculation like this. Look, BaCl2. Look, it contains Ba and it contains chloride. How many chlorides? 2. How many Ba? 1. So these are products. You can write like this. H2O, Ba plus 2 and 2 chlorides. Look, it's very easy. Another one, another example. Look. Another example. AlCl3, it contains Al, 1 Al, of course, Al plus 3, and it contains chloride negative, which is 3. So if we continue the reaction, 1 Al, Al plus 3, and 3 chlorides. You see how it's easy? Okay, the only thing that needs, it just takes a time, nothing at all. Just be a patient, everything will go smoothly. Well, let's get back to the pamphlet. Now, let's solve that kind of question. You will face that kind of question in the final examination each year, each semesters. Okay, look, how to solve that kind of question. Stay with me. Look, write the equation for the dissolution of aluminum sulfate. First of all, point at your compound. Look, during reading the formula of the question, you have to know what is your compound. So point at your compound. Our compound is aluminum sulfate. First of all, aluminum sulfate. But name, it's not everything. You have to know its formula. Okay, you have to know its formula. First step, point at your compound and you have to know its formula, please. Formula, it's very important. Well, aluminum sulfate is, luckily, it gives us the formula. Al2SO4 by 3. Look. Al2SO4 by 3. This is aluminum sulfate. Okay. Write the equation for the dissolution of aluminum sulfate in water. Then, how many moles of aluminum ions and sulfate ions are produced by dissolving 1 mole of aluminum sulfate? And what's the total number of mole of the ions that can be produced? Well, how to solve that kind of question? As I told you, first step, point at your compound. Point at your compound, please. And then write its formula. Al2SO4 by 3. First step, write the dissociation reaction. Okay, write the dissociation reaction. H2O must be right above the arrow. We have 2Al plus 3 and 3SO4. Negative 2. Okay. Well, first step, write the dissociation reaction for 1 mole of a compound. Look, we have 1 mole. 1 mole. Write the dissociation reaction for 1 mole of a compound. Okay? Firstly, you have to know 1 mole of compound yields how many ions with their number of each individual ions. First step, write the dissociation reaction for 1 mole of a compound. Then make a calculation for that reaction. For that reaction, when we write the dissociation reaction, make the calculation for that reaction. Okay. Here we have 1 mole, 1 mole. Okay. How many moles of aluminum cation? 2. 2 moles. Look. 2 moles. Okay. And here, how many moles of sulfate anions? 3 moles. Okay. Look. If we dissolve 1 mole of aluminum sulfate in water, we will get 2 moles of aluminum ions and 3 moles of sulfate anions. You know how it's easy? Look. How many moles of aluminum? 2. And sulfate ions? 3. Okay. And what about the total? The total will be 2 plus 3. It will be 5 moles as a total. Okay? Still, we didn't read all the question. We didn't read the question completely. Okay, first step. Take out your compound, write the dissociation reaction for 1 mole, and make the calculation. Then, continue to read the question. You will see a number. Okay, you will see a number. Okay, let's see. Are produced by dissolving 1 mole. Okay. Because of this question asked for 1 mole, so we already made our calculation. So the total will be 5 moles, and aluminum is 2, sulfate is 3. That's all. It's very easy. Okay. But what if we have this formula? Then calculate the number of mole of aluminum and sulfate and total when 2 moles of aluminum sulfate is dissociated. 2 moles. Then what if we have 2 moles? You have to multiply by 2. 2 times 2 equals to 4. 3 times 2 equals to 6. And total will be 4 plus 6, it will be 10. What if we have 3? Multiply by 3. 2 times 3. Then 3 times 3. Total will be. Okay? Now I think you understand well why we finish just right there. Because of the question asked for 1 mole. No more. What if it's more than 1? We have to make that kind of calculation. Okay. Another question. Another question. Don't worry. Another question. Okay. Another question. Write the equation for the dissolution of 0.5 mole of barium nitrate. Remember what I told you? First step. What is your compound? Okay, our compound is barium nitrate. And the formula, oh, mister, we don't have the formula, so it's a big problem. No, it's not a problem. If you know how to write its formula, it's not a problem. Barium nitrate, for me, it's for you, it's so simple. It's BaNO3 by 2. That's all. Okay. So first step, write the dissociation for 1 mole. Okay. BaNO3 by 2 water. It will be Ba plus 2 plus 2NO3 negative. Okay. It's a dissociation for 1 mole of a compound. It's so easy, right? Then make your calculation for this reaction. 1 mole. We have 1 mole of barium and 2 moles. So if we dissociate 1 mole of barium nitrate, we're going to get 1 mole of barium and 2 moles of nitrate. So in the total will be 3 moles of ions as a total. Okay? Well, and now continue the question. Look, make your calculation for 0.5 mole of barium nitrate. 0.5 mole of barium nitrate. What if we have 0.5? So you have to multiply 1 by 0.5, 2 by 0.5. It will be 1 and it will be 0.5. So the total will be 1.5 moles. That's all. Okay? Look, easy and peasy. First step, take out your compound, write the dissociation for 1 mole, then make your calculation for 1 mole, and after that read the question till the end. What if we dissolve 0.5? Okay, multiply your result by 0.5. Nothing more. Well, another one. Don't be upset. Which of the following can dissociate into water? Okay, let's answer that kind of question. Which of the following can dissociate? Dissociate. First of all, dissociation, remember, the process of dissociation happens only for the ionic compound. So that means we have to look for the ionic compound. It's salt. Salt is ionic compound. Salt again is ionic compound. Strong base. Strong base. Strong base. It's ionic compound. So all of them will dissociate if we put each individual of those compounds into water. Okay, let me write the equation. In water, it will be Na plus Cl negative. In water, it will be K plus Cl negative. In water, it will be Na plus OH negative. So all of them dissociate in water. Easily. Okay. Now, actually, this question is a wonderful question, and for the first semester, we have seen this question exactly for this year. Well, look, for 0.75 liter solution of 2 molar ammonium sulfide, calculate number of mole of ions. Number of mole of ions. So that means we have to write the dissociation reaction for 1 mole as a first step. In order to get the safe dissociation reaction, we have to know the formula. Okay, first of all, our compound is ammonium sulfide. Ammonium sulfide. What is the formula? Luckily, we get the formula by the question. Very good. NH4 by 2S. First step, write the dissociation. Look, NH4 by 2S. If we dissolve NH4 by 2S in water, we will get 2 ammonium cations plus 1 sulfide anion. Easy. Okay. And now make your calculation for 1 mole. Okay. Still, I didn't read the question. Still, really, I'm just looking for a compound and then write the dissociation for 1 mole. Nothing at all. Okay. 1 mole yields 2 moles of ammonium and 1 mole of sulfide. So the total will be 3 moles. Okay. But look, the known information must be in mole. But now we can see we have volume and molarity. So what we have to do? We have to calculate number of moles. How we can get number of moles if we have liter and molarity? How we can get number of moles? Okay, you have to remember that. You studied that kind of question many times. Last year, of course. Look, molarity equals to, well, I will do this in other corner here. Molarity equal to mole per liter. We have molarity 2, liter is 0.75, okay? Liter is 0.75. And we are looking for mole. So cross product, mole equals to 2 times 0.75. So mole will be 1.5 mole. So what if we have 1.5 mole? Multiply 2 times 1.5 and 1 times 1.5. It will be 2 times 1.5, it will be 3. It's 1.5, so 1.5 plus 3 equals to 4.5 moles of ions. Nothing new? Still nothing new, okay? Look, first step, write the dissociation reaction for 1 mole of your compound, then make your calculation for that mole, and after that, read the question. We're going to see a number in units of mole. If not, you have to turn it into number of mole. Look, because of in this question we have liter and molarity, so we convert those informations into number of mole. Then we have to use this number and make your mathematical operation to get the last result. Well, continue. Another question. This question. Let's see. How many moles of sodium phosphate must be dissociated? How many moles of sodium phosphate must be dissociated to produce 1.6 mole of ions? This is exactly reverse of the previous questions. Let's see. Look, first step, don't change the rule, please. Point at your compound. Our compound is sodium phosphate. Okay. Sodium phosphate. Sodium phosphate is Na3PO4. Okay? Then dissociate 1 mole H2O to producing 3Na plus phosphate -3. Then make your calculation for that mole, 3 mole and 1 mole for 1 mole of sodium phosphate. But now let's see. How many moles of sodium phosphate must be dissociated? Look, how many moles of that compound must be dissociated? When you see must be dissociated, that means the unknown is in this side, in a molecular side, in a compound side. So here must be X. The total is 4, right? So I want to make the calculation in a better way. Look. Good. This is 3 mole. It's 1 mole for 1 mole. Right? So total is 4 for 1 mole of a compound. But now, how many moles of that compound must be dissociated, X, to get 1.6 mole of ions? 1.6. So that means we have 4 mole of ions if we dissociate 1 mole of a compound. But what if we have 1.6 mole of ions? How many moles of that compound must be dissociated? X. then cross product x equals to 1.6 divided by 4, it will be 0.4 mole of ions. So the right answer is B. B is 0.4 mole of ions. So please be careful if you see this phrase must be dissociated. That means here is unknown. Here is unknown. So this side must be known. If you see must be dissociated, here is X. So this side is known. Well, I want to see we have more questions. If not, we're going to finish this lecture. Well, this is last question, and by the end of this lecture, we're going to explain this question. Look, how many moles of ammonium sulfide must be dissociated? Look, hopefully you remember. Must be dissociated. If you see must be dissociated, that means X is in this side. Here will be X. So first step, take out your compound, point at your compound, and write the dissociation for 1 mole. Look, ammonium sulfide result is 2 moles of ammonium cation and 1 mole of, well, it's S. It's not sulfide, it's S negative 2. Okay? Ammonium sulfide, and it's S also. Good. Look. For 1 mole, we will get 2 moles of ammonium and 1 mole. Okay, how many moles of ammonium sulfide must be dissociated to produce 0.6? So for 1 mole, we will get 3 moles. Look, for 1 mole, we will get 3 moles. This is NH4 by 2S, and it's ions. Look, for 1 mole of the compound yields 3 moles of iron. But what if we have 0.6 moles of ammonium? Look, this time, it talks about only ammonium, not total number of mole of ions. That's why we have to forget about the other. Look, ammonium ion, only ammonium. So, for 1 mole, we will get 2 moles of ammonium. But what if we get 0.6? You have to put X. Then make your cross product. You're going to get the last result. بەم شێوەیە کۆتاییمان بۆ بابەتەی هێنا چۆنەتی دۆزینەوەی mole of ions if we have dissociation process. ئینشاڵڵا سوودتان لێ بینیە. سەبرتان هەبی لەوانەکانی دی شتی زیاتر لەسەر دەخوێنین و زیاتر شارەزا و ئاشنای ئەو بابەتەی دەبن. تاوانێ داهاتوو بەخواتان دەسپێرم خواتان لەگەڵ.